My name is Mary Napolitano, and it's my pleasure to talk to you today about Standard Imaging's IMSure QA software. In short, IMSure is second check software that is reliable, quick, and easy to use. Here are some of my colleagues at Standard Imaging. Standard Imaging employees during these challenging times are proud to help with your radiation, calibration, and quality assurance needs. Let's go over a bit of housekeeping before we get started. Today's webinar will be recorded, so please enter questions at any time during the presentation into the GoToMeeting dialog box. I will answer all questions at the end of the presentation. Standard Imaging is based in Middleton, Wisconsin, and was founded about a little over 30 years ago. On this slide is a picture of the back of our office in Middleton, Wisconsin. Like many of you, because my position allows, I am working from my home today. At Standard Imaging, we design and manufacture a full suite of QA products. Standard Imaging has several patient QA products. Adaptivo, which consists of modules for pre-treatment and during treatment QA, both integrating EPID images as well as an automated adaptive dose reconstruction module that provides automatic notification of deviation so that appropriate action can be taken at the appropriate time. Linac View is an automated log file-based plan comparison software. It monitors and provides alerts based on user-specific parameters for every treatment. And IMSure is the product that I will be covering in more detail today. So where does QA using IMSure fit into the patient workflow? The gray boxes with blue arrows depict the simplified steps with the input and output of each step in the treatment workflow. So the input and the output for IMSure are depicted in the light green. Device-specific commissioning data, as well as patient-specific information, are incorporated into your TPS. Prior to use, device-specific information, be it for your Linac, traditional Linac CyberKnife, or the consensus data for your brachytherapy seeds, are incorporated and commissioned for use in IMSure. So then, once a calculation is complete in the treatment planning system, the RT plan and optionally structure set, CT images, and Fluence maps are exported and collected by IMSure's DICOM listener. After import into IMSure, calculations occur and the physicist reviews the plan details compared to the TPS result for parameters such as the monitor unit, calc points, and Fluence maps. Then after review, a report is generated and attached to the patient record. And so that's essentially the IMSure workflow and where it fits into the patient treatment. So in today's webinar, I'll try to answer the question, why use IMSure? First, I'll give you a brief overview of each of the 4 calculation modules, as well as provide some details on the required input parameters as I step through each of the modules. The 4 calculation modules are the MU module, which is a single source model, typically used for 3D conformal plans, SRS cones, and electrons. The second module is a QA module, which is based on a 3-source model. And this module is typically used for VMAT and IMRT plans and provides Fluence map comparison as well. We have a CyberKnife module and a Brachytherapy module. And this screenshot shows you the icons that one would select to enter each of these modules, the QA, MU, CyberKnife, and Brachy module. And then as well, we have the physics module where you do your commissioning of the data that you import, and then preferences, and the print icon provides the report. So I'll start with the MU module. The traditional calculation by Dr. Khan is what's behind this module. The MU calculation is based primarily on determining the effective depth combined with the effective field size in the plane of the isocenter, along with the divergent factors from which the appropriate TMR, head scatter, and phantom scatter factors are determined and used for the calculations. So, just a little figure. This is from our manual. Your typical setup where you acquired your measurements, with your water tank at a particular SSD and depth, your source, the central axis, and isocenter here. Of course, your calc point is going to be off axis, and then the patient surface will not be parallel to the source and may have a divergence that it'll need to be corrected for. And so then based on this geometry where this is your patient surface, there's a projected SSD and a projected depth, and of course your off-axis distances, which are used in the equation, the MU equation, which I've put in the next slide. And this should look familiar to all of you, where the MU is calculated based on the prescription dose to the calculation point, isodose at the calculation point, tissue maximum ratio, the off-axis correction factors, wedge factors, phantom and collimator scatter factors, etc. And then finally, the dose is calculated for each point using the equation at the bottom of the page. Specifics for the IMSure calculation are further detailed in the references by Zing et al., as well as in the IMSure manual. So next, in the MU module, if you're doing an electron calculation, the equation is slightly different, of course. Where the MU calculation is based on the dose prescribed to the calc point, the particular cone output factories, output factor, the cone factor for the particular cone and field size, off-axis correction factors, etc. Very similar equation. So next, moving on to the QA module, where one would do calculations for IMRT and VMAT plans. One can review a 2D Fluence map along with the dose points in this module. This three-source model, which was developed by Yang et al. From Stanford, consists of a primary photon source, which is placed at the target of the LINAC. There are two scatter photon sources, one positioned at the base of the flattening filter, which is it's a disk source in approximately this region. And then the second scatter photon source is it's an annulus shaped source to match the bottom of the primary collimator position. And then, of course, these specific positions change with your LINAC manufacturer and type. And there are defaults for the different LINACs when you go to set up your model, as well as they're modifiable by the customer as well during the commissioning process. As well, there are leaf and jaw transmission contributions for the incorporation of the calculation of the Fluence map, and so depicted here, your leaves and your jaws. And here's another figure from the Yang reference, and shows a projection depicting a slice through the Y jaw and two of the source planes. And you can look at this from the detector eye view down here, looking up at the source. The equation is shown here for the total energy fluence, which is comprised of the primary component, the scatter component from the primary collimator is the second term, and the third term is the photon scatter component from the flattening filter term. And of course, you can see if the SCD is equal to the SAD, then the equations are much simplified. And then one can look at the additionally at the components. It's a constant source term for the primary, a constant for certain radii for the scatter primary collimator, and then it's an exponential source that varies with the radius of the disk for the flattening filter source. Also, for irregularly shaped fields, the fluence is calculated using the sum of the projected areas of subfields formed by each leaf pair. Our manual provides additional details concerning the IMSure calculations for those that are interested. So getting down to a little more about the basics of the software, the use of it. So after plan import, there's automatic calculation of the monitor units and calc points. In addition, if one should choose to import Fluence map, the calculation of the 2D Fluence map is then performed, and then one must analyze the Fluence versus the treatment planning Fluence. And of course, you have your standard tools, your gamma analysis and percent difference. Here you can see the gamma map, and over here I have some screenshots of the histograms for the difference map and the histogram for the gamma map, as well as you can see the pass rates in the software as well. I'll go into further detail about the QA module during the software demo later in the presentation, but you can see all the basics are here with the calc points and the MU information on a per beam basis. So what physics data is needed? So the typical commissioning data is required to create your LINAC photon model for IMSure. Shown are the data for open and wedge fields, and similar data is required for the electron model. Of course, the TMR profiles for the largest field size at multiple depths, output factors as a function of field size, head scatter factors at the same field sizes, of course, the absolute calibration at a specific SSD and depth, and the wedge beam measurements as well. So the next screenshot I'm showing is from the physics module, and this is where you would generate your models for your LINAC as well as for your and so you would have the information where you would be able to import your TMR tables, OCR tables, output factor tables, scatter tables. We support LINACs for Electrovariant, Siemens, and CyberKnife. The beam types you can generate models for are your standard flattened beams as well as SRS beams if you would like to create a model more focused on your small field sizes. So have a standard model for your more traditional deliveries, and then optimize for the small fields. You can have separate models there. You can as well have, we support flattening filter free as well as cones. And then here you can see, after you import, you can see the table, for this example, the TMR tables. And then, of course, you can go over and select graph, and you can see the graphics so you can easily check your imported data. Many types of external beam plans are supported, for example, wedges, photon and electron plans, as well as mixed photon and electron plans, SRS plans with cones, IMRT, VMAT. So next, let's move on to the brachytherapy module. We support both HDR and LDR plans, and they are supported based on the TG43 formalism shown here. And this, of course, is a screenshot showing some of the consensus data imported and also graphed for your convenience in the IMSure software, so you can check your data. This one is in particular for the Theragenics source, model 200. And of course, here's your diagram of the geometry that's shown with the TG43 formalism, your brachytherapy source, and you're calculating the dose rate to a point at this position at a radius r and angle theta. So here's your equation. You're calculating your dose rate based on the air Kerma strength, your dose rate constant, your geometry factor at the specific position for the source, the nominal divided by the nominal geometry factor at the reference position of R naught 1 centimeter, theta at 0 degrees at the position perpendicular to the bisector of the source, multiplied by your radial dose function and your anisotropy function. And so just calculating dose to a point is the objective of the TG43 formalism. And of course, with each source in place, either in a dwell position for an HDR source or the implanted position for the LDR sources, then this formalism is used to produce the composite dose at a particular point for your plan. So, of course, you have your calc points and your, as I previously stated, your contribution from every dwell or source position. And within IMSure, you can see the graphics for the positions of the different sources. And then down here at the bottom, you can see the composite dose for the imported plan versus the IMSure second check calculation and the difference between the two. And so this is for the point, which is highlighted in yellow for this particular plan. And then as well, if you'd like to look further, you can see for each and every dwell position, the contribution of the dose from each and every dwell position. And then you can, of course, these are the specific parameters that comprise the TG43 formalism, and they're all listed here as well for your review. The next module is the CyberKnife module. And in this module, it requires similar input to the traditional Linux, your TMR, your off-axis curves, and output factors. And so we can look at the comparison of composite results. Up here at the top in the corner, the TPS dose, IMSure dose percent difference. Again, the monitor units from both and percent difference. And then it also gives you some extra information about the total number of beams or nodes in this particular plan. And then the difference you're seeing for each of the nodes. None of the nodes show variation greater than 5%. 73% are at 2% or higher, and 18% are between 0 and 2%. So that's a nice summary up at the top. And then in addition, you can compare the dose difference and the MU difference for each node in particular. We support multi-plan and up through Precision 1.0 for fixed collimators and iris. And we compare, of course, the monitor unit and the dose in the CyberKnife plans. And so finally, no QA is done without the report. So we, of course, can create PDF reports. This is a sample of the front page of the plan I'm going to be showing you in the demo. There are 13 pages by default for this report. You can select the details via checkboxes that you'd like to appear in your report in order to customize it. We can create reports in English, French, or Portuguese. And as well, we can export the results to a CSV file so that you can import into Excel if so desired. And so now I'm going to go and just show you the software very briefly for one plan, just so you can get the look and feel of the software. And before the webinar started, I went ahead and opened up the software and I imported a particular plan just using this button, and I had gone no further. When you import the plan, it merely queries and looks at all the plans that are available and sent and received by the DICOM listener. And I just imported the top plan here. You can see some information about it. 11 beams and 9 Fluence maps. But I'm going to cancel since it's already sitting here, and I went ahead and I calculated the Fluence map as well, which you can see here. And since I just calculated the Fluence map, this is it. And of course, you can look at it for all the different fields and segments if you want to peruse through. Here we show the beams. 2 of them are setup beams, but you can look beam by beam. As well, you can go over and check out your calc points. This plan only has 1 calc point. And you can see here the TPS versus IMSure dose agreement. It's very close. Of course, some of the beams have percent differences that are larger. This one in particular, beam number 9, you can take a look at it. You can see that the contribution is very small to the calc point, so it's not contributing significantly to your calc point, and you can just flip through all of the calc points. In addition, of course, you can look at the gamma comparison. In this map, anything that shows as red is failing. And you can look at the gamma comparison for each of the fields, flip through the different segments if you'd like. As well, I showed the histogram comparison screenshot already, but here it is again. And you can look at the histogram on a field by field basis. And any values that show in blue are cold, the ones in red are hot. And then down here for the difference map, for the gamma map, there are different shades of gray for those values below 1 and in red if you're failing. And this one in particular, it's 0.3 centimeter with 3% difference. And of course, that's modifiable by the user. Other than that, I mean, it's really quick, it's straightforward. You import your plan. To generate your report, you just click print. You can review the beams and the calc points and look through. And when you import the CTs, then you can determine the effective depths, as well as just give you a look and see where the calc point is in reference to your structures. If you choose to import structures as well, we don't require that, but it's just good for the review to have the structures and the CTs, of course, to assist the effective depths. And finally, one can print and preview and see the reports very quickly and easily and export those out. And that concludes my software demo. And so IMSure, it's very easy to use. It's fast second check software, and you can get up and going with IMSure very quickly and easily in your clinic. Have a good day, and thank you very much for your attention.